because this guy's in here. All right, you guys ready? Class?
Yes.
You guys know I'm joking, right? Anyway, all right, so we're going to finish up these notes, and this method right here is, I find it, if I was going to do it by hand, this method is easiest. But it just takes the most steps. It's just a step by step, okay? That's the part with this that's actually going to make it more complicated because there's multiple steps. So I need you taking good notes for these multiple steps. I'm going to do this one and one more, then I'm going to give you some time. I'm going to look at how you guys are doing the problems, and then I'm going to let you work on the homework. So, right here, if you want to read all this, this is in Mathanese. Okay, most people don't speak Mathanese, so I'm going to put it in basic terminology. I'm going to put it so everyone could actually understand. You don't have to be a degree in math. So right here it says solve by addition method. Now what the addition method is, you draw a line and then you add. But for this to work, one of my variables, either the x or the y, when you add them together, has to equal 0. Has to equal 0. So either the x or the y is going to equal 0. So now let's look when we're combining these right now. What is 3 and 9 going to give me? 12. So that's not going to be equal 0, is it? Dang. What a crap. Okay. Now, positive 2, negative 8. That's going to give me negative 6, right? So neither of these variables right here is going to add up to 0. So what I'm going to do right here, is I'm going to have to multiply. So I'm going to distribute by looking at common factors. So one of these has to be a negative and the other one has to be a positive when I do this. So can I multiply 3 by something to get 9?
Yeah.
Yes. So the common factor there will be 9. Let's look at the other one. Can I multiply 2 by something to give me 8? Okay, so that is going to be a common factor. 8 will be a common factor there. Now, for them, like I said, they have to give me 0. What's going to happen for something to give me 0? I have to have a positive and a negative together when I add those together to give me 0. And that's what I'm trying to do with the addition method. I am combining them to get 0. Yes, is that what you're saying? Yes, very good. So what I'm going to do is, because the 2 right here is already positive, and the 8y is already negative, what I'm going to do is I'm going to distribute. I'm going to multiply by this whole thing by a common factor, which will make it into a positive 8. Because I want these y's to cancel out. So what number do I have to multiply by everything to get positive 8 there? 4. Very good. So I'm going to do 4. Okay, 4 is going to be the common factor, which is going to make that y's, when I add them together, to be 0. Let's go ahead and distribute this. So 4 times 3x is going to give me, very good, 12x. 4 times 2y, 8y. It's a positive 8y, isn't it? So the sign's going to go with it. Positive 8y. Bring down my equal sign. And then my 4 times 48. 192. So by distributing that in, it's still equivalent to the same thing because I multiplied the left side by 4 and the right side by 4. So it's still going to be the same equation. It's just going to look different because it's a bigger factor here. Now I could take this and I could combine or add these together. That's what I'm trying to do. I'm trying to get this so I can cancel out one of my variables. So let's go ahead and combine these together right now. So if I combine those together, I got 9x and 12x. So together, how many x's do we got? Which is it? 21. Okay? So, because we have 9 x's over there, and we got 12 x's over there, so together there is 21 x's. Now, that negative 8y and that positive 8y, what's that going to give me? 0. 0y. And this is what I'm going to do here. Since that's going to be 0, what I want you guys to do, I'm not going to bring anything down, because when you bring it down, it ends up becoming confusing later on. Because when it's 0, it's canceled out. It goes away. It is gone. So there's no longer any y's. So all I have as a variable is just x's left. So I bring this down, equal sign here, and now I combine my negative 24 and my positive 192. What is it? 168. So I get 168 here. On that 168, okay, I'm trying to get x by itself. So what do I have to do to both sides to get x by itself? Very good. Divide by 21. 21. So x is, very good. Now, this is a system of equations. It's a system. So I have a value for x, and I still need the value for y. So this is what I'm going to do with that x. I'm going to take that 8, and I'm going to plug it back into either one of them. So it doesn't matter. I'm going to plug it in to the first one. I'm going to plug it into the first one. It doesn't matter which one I plug it into. I can plug it into the top one or the bottom one. So wherever I see my x value, I'm now going to write what? 8. I'm going to write it 8. So right here, we're plugging it in. So it's going to be 3 parentheses 8. Very good. Close. Plus 2y equals 48. Now, since I plugged in my x, I only have one variable now, right? I only have y. So I could solve for this since I only have y. 3 times 8 is? 24? Okay. So 24 plus 2y equals 48. What do we do with that 24 there now? Very good. Subtract it from both sides. So let's bring down my 2y is going to equal to 24. Divide both sides by? Nah, come on. Is there any more? Is that how I leave my answer? Say no. No. You put it as a point. 8, comma, 12. Make sense, hopefully? Okay, so I'm glad everyone's going with this, right? So now, I'm going to do one more example, then I'm going to go over some homework stuff for you, okay? Yes? Because we're getting some homework done today. Wait, no. There we go. Linear system having no solution or infinite many solutions. So I'm going to do this next example, but I'm going to skip the example after it because it's actually pretty easy. So exactly one ordered pair, when I have 2 lines that cross, they cross only at one singular point. If I have a parallel line The definition of parallel means that they go in the same direction, never go farther apart, and never touch, right? So parallel lines will never intersect. So there is no solution for parallel lines. This one right here, you can tell, this one is an infinitely many solutions. That means that one line is on top of the other, so both lines are touching at every single point. That's what that is right there. One line is on top of the same line. So let's take a look here. Now, in this example here, I have to again look to see. I'm going to either cancel out my x's or cancel out my y's. So by using addition, let's look. 4 and 6, are those going to give me 0? No. 6 and 9, are those going to give me 0? No. So now we have to start looking at factors. Factors. Can I multiply 4 to get 6? No. 6 to get 4? No. What about 9 to, or 6 to get 9? 9 to get 6? No. But they're going to have a common factor. The common factor is where will they both equal the same number? What you got? Okay, so I can use 18, right? So I can use 18 for the y's. Because again, we're going to have a positive or a negative. We're going to have a positive and a negative for both of them together, right? So you said 18 on this. So to get 18 for my y's, I would have to multiply this top one here by what? I'm going to use -3. Very good. So I'm going to use -3 because one of them has to be negative. Because right now they're both positive, right? And so I need to make one of them negative. Now, the one below it, okay, so if you have positive 18 and positive 18, will those cancel? That would give you positive 36, right? You don't want positive 36. So if you have positive 18 and negative 18, when you combine those together, you get, say, 0. Yes? Did I answer your question? I don't know who the question was, so yeah, that was you? Okay, so yeah, I just need one to be positive, one to be negative, because when I add them together, I have to get 0. Does that make sense? No? Tatiana? No? It doesn't make sense? Okay, if you have $18, how are you going to get 0? You're going to spend, you're going to subtract $18, right? So, if you have a positive, to make it into 0, you have to subtract 18. If I have a negative 18, to make that to 0, I need to add 18, right? So the common factor, which we picked this out, is going to be 18. Now, if you don't know what the common factor is going to be, the easiest way to do that would be multiply the two numbers together. So I would multiply the top number by 9 and the bottom number by 6, right? Does that make sense? No? Top number by? No. If you don't know that it was 18. If you don't know it's 18, you would multiply the top by 9 and the bottom by 6. Does that make sense? Yes? It just gives you a lot bigger of a number. But it's still going to work. Go ahead. This one's going to be 2 right here, right? Because this is going to be, this is going to be 18 here, right? So I want my y values to be 18. So I'm going to do my distribution, and then we're going to look at it. So -3 times 4x. -12x, very good. So bring that down, so -12x, right, Mercutio? So -3 times positive 6y. -3 times positive 6y. So it's going to be -18y. So I get negative 18y. So negative 3 times, so bring down my equal sign, negative 3 times positive 12. Negative 36. All right, we're doing it again. So now on the bottom, I'm distributing that one by 2. That one's going to be a positive 2, so let's distribute. So 2 times positive 6x, positive 12x. Positive 2 times positive 9y. Positive 18y. Okay, if you notice I'm putting the plus sign there to show it's positive. Bring down my equals. And 2 times 12, 24. So now I'm going to combine. I have set this up so my y value should cancel. Yeah. Yeah, the x values are also going to cancel. I'm gonna read this off as I go. So now, I normally am not going to put 0, but I'll put 0 here to show you, to give you a definition of this. So negative 12x, positive 12x is going to give me 0x, right? Negative 18y, positive 18y is going to give me 0y equals negative 36, positive 24. Yep, negative 12. Now, this one right here, 0x plus 0y, is that possible to equal negative 12? You add 2 zeros together and all of a sudden, boom, it's negative 12. That one's no solution. Now, I'm not going to do the next example, so this is a no solution example. So I'll show you an example of infinite solution. Infinite solution, your answer is going to look like this. 0x plus 0y equals 0. So when you actually do the combining on this and you get 0x plus 0y equals 0, look, you have nothing, and together, boom, it's still nothing. That works infinitely, all the time. Every time you multiply nothing and nothing, you always get nothing. So that's your infinite solutions. That wouldn't work. Yeah, because if it was 1, 1, 1, that would work because you would have 1x. There is an x. So there is an x and there is a y, and then together somehow those are going to combine to equal 1. Does that make sense? So it's like, hey, this one's got 50 cents and the other one's got 50 cents. I combine that. Is that going to equal 1? Yeah, so that is possible. But when you do this right here, like we did with this addition method, if you come up with 0, 0, and 0, infinite solutions. 0, 0, any other number besides 0, it's going to be no solution. Yes? Imaginary. Yeah, it will be parallel lines, but you're looking for a solution, remember. You want it to cross, and it's not going to cross unless it's imaginary. But that takes us into another crazy bit. Like someone pulling their laptop back out and trying to do notes while I'm talking. Okay? Right here. It is the straight line on top of itself. So both lines are on top of each other right there. Does that make sense? Okay, and that one's a parallel. That one is no solution. Yes? Okay. Alright, so this is what I'm going to do. Since I said I'm going to skip number 8, I'm going to stop right here. I'm going to pause, and I want everyone to start on number 25. Alright, let's continue here. So, class. Okay, so it looks like I think I got just about everyone checked out to make sure you're on the right path. You know what you're supposed to be doing. Okay, I'm sorry if I didn't make it around to everyone. I tried, okay, but certain people wouldn't let me go, okay? So, I had to go back to the same people over and over again.
That's not fair.
Huh? It's not fair, right? You're taking up all that time. All right, so example 8, I told you I'm skipping that. We're going over to 9, or not 9, but yeah, it's going to be 9. So linear system having no solution. Oh, we already did this one. Bam. Okay, modeling systems of equations making money and losing money. So this example here. So there is a problem like this that it's going to be on the test. You're going to have two equations. One is going to be, okay, the revenue. That means how much money you make. Price per unit sold. Something times X. Okay? Cost function is going to be the fixed cost, whatever it is. So I like throwing in, Tesla here. So think about it like this. Tesla, those cars, electric cars, right? Now, when they first started coming out with electric cars, weren't they like $150,000, $200,000? Yeah, they were pretty expensive, weren't they? Yeah, the Roadsters, all the ones, the really nice ones they came out with. Yeah, they were expensive, but what they did is that was their initial investment. So they needed a factory, they needed to hire workers, they needed to have designs, they had to have all these things, all these tools to build these cars. And before they even could build a single car, they had to have a certain amount of money that they put down in the first place to even build the first car. That's what their fixed cost was. So their fixed cost is something just so you could build a car. And then it goes price per unit produced. So each car, now you have to look at how much money you're going to make per each car. So if I sell a car, I sell it for, let's say for instance, I sell it for $150,000. It costs them $100,000 worth of material, $100,000 worth of parts, labor, batteries, electric motors, all that stuff is going to be about $100,000. So when they sell it, each one of those do simple math. Okay, how much are they making off each one? If they sell it for, it's going to be $50,000. If they sell it for $150 and it costs them only $100 to make it, so their investment is slowly being paid off the more cars they sell, right? Because they're making $50,000 over every single car, right? So after all that initial investment is paid off, that's the reason why all the factories are paid off, all the building is paid off, the tools, they have all that. So what they could do now you can go buy a Tesla, which is like $30,000, $40,000. It's the average cost of a car right now, is getting a Tesla. So that's what they did by taking care of their fixed cost, which is our initial investment, and then cost per unit produced. So they don't have to do the fixed cost every time anymore, because they already have their buildings built. So right here it says finding a break-even point. Oh wait, I gotta go back to break-even. Now on the bottom, so point of intersection, where those two lines cross, the graph is the revenue and the cost function is called the break-even point. That means that, let's say for instance, it costs me that, what did I say, like $100,000, something like that, to buy all those things, your building, your tools, all that. And so each one of those, so since you only make $50,000 off each one, you're going to have a break-even point. So if I sell 0, I lose a bunch of money, right? If I only sell 1, I'm still losing money, right? But at a certain point, when I sell enough, I break even. That's the point I'm looking for. That if I sell enough, I break even. So everything above that, everything you sell above that is going to be all profit, because you've already taken care of all the prices. So that's going to be the break-even point. Now, all this stuff, it might sound kind of complicated, but it's in your notes. Can you use your notes on your test? Yes. That's the reason why I want you guys taking good notes right now, because paying attention, going over this, making sure everything is taken care of. So a company is planning to manufacture radically different wheelchairs. Fixed costs will be $500,000. So the fixed cost is going to be the cost of buying the building, buying the tools, hiring all the employees to make sure that you're able to even build. Before you even build one, you have to have all those. So that's going to be my fixed cost right there. And it will cost $400 to produce each wheelchair. Each wheelchair will be sold for $600. If it costs me $400 to make it and $600 to sell it, right? So how much am I making any money off of that? Each one I'm going to make how much? Each one I'm going to make $200. So that's a good thing to actually know right now. So we're going to go through and actually do all these parts. So the cost function is the sum of the fixed cost and the variable cost. So my fixed cost, so cost function is going to be my fixed cost, which is $500,000, plus the variable cost. What did it cost me to produce one wheelchair? $400. So it's $400 per wheelchair, right there, X. Now the next one, it says the revenue function is the money generated from the sale of X wheelchairs. So that's going to be my R. So it's going to be my revenue of X. How much did I make on each, or how much did I sell each wheelchair for? 600 for each wheelchair X. Does that make sense? I'm just plugging in numbers here. Right? You're just plugging in numbers. Part C, we are going to find the break-even point. So I'm going to take my calculator, because I don't want to do this because these are big numbers. Right, Michael? Okay. Try to stay awake, please. So calculator is your friend. Go to my documents, go to Scratchpad here. So clear your Scratchpad, because if you did your warm-up, it's in the wrong mode right now. How do you clear the Scratchpad? Doc B, clear the Scratchpad, please. So these problems, Mercutio, you doing all right? These problems right here, are these written as standard form? Are they x plus y on one side? Say no. No. These are regular functions. So these are cost functions right here. These are cost functions. So what yours is going to look like is going to be F1 of x is going to be your 500,000 plus 400x. F2 is going to be your 600x. So I'm writing this down like this because this is what it's going to look like in the calculator. This is where it's going to look like. So, in the calculator, so I have my first function right here, which is my 500,000 plus 400x. I'm going to hit enter. But why is it not on my screen? Huh? I did the right steps. Why is it not on my screen? Not because I have to do another one. What do you got? Yeah, I'm zoomed in too much, right? My initial cost is $500,000, right? But my graph only goes to 6. That's not going to work out for me, is it? So I'm going to show you a couple things to change your windows. And now let's do tab to enter my second one. 600x. X. Hit enter. Alright, I have the second one on here now. Now from here, I want to be able to see it. I can't see it though. So I'm going to go, so I know you guys are writing these steps down because they're important. They're important, especially on this problem here. Menu. And what do you think I need to change? Windows. And there's a couple things I'm going to do. I'm going to go straight to Windows settings on this. Now, think about your X-min. What does X stand for? Okay, but what are we using? What is X representing in this word problem? Quantity sold, right? Can you sell negative? No, but you could sell positive. And can you sell 0? Yeah, you could sell 0. You're just not a very good businessman. So I'm going to change my X-min to be 0. My X-max. Because I'm only going to make $200 every time, right? I'm only going to make $200 every time, and I got to try and make more than, I have to make up more than $500,000, right? So, I don't know. Let's take this up to like 10,000. Because maybe I need to sell 10,000 wheelchairs. What's up? Someone's gone. No, there's different people have gone. Now, Y min, the Y minimum. 0, right? Because I'm already starting with $500,000 that I owe. It's my initial cost. And max. Remember, this is the money. This is the money. So if I'm already at 500,000 and I'm gonna have to like sell a whole bunch, put it up to like 2 million. Let's see if that works. Let's try 2 million. Because in these word problems, you have to understand that if you take your phone out, Pacha's going to get pissed. And yes, I can see it underneath the desk. It's not you this time. Yeah, it's a calculator. Hit enter. Alright, hey look, I got it here. Now, these calculators are super smart. So what you could do, if you did not see an intersection, but you see something like this, what you can do is you click on the screen and hold it. And then slide your mouse pad in one direction. Okay, because they do have a mouse on it, so you can slide it. And I found my intersection is right there. So I could just grab the screen and move it to whichever place I need to. So if I need to just keep dragging it up or dragging it down, I can. Smart calculator, right? Now, I'm looking for the break point. So this is going to be the break point. This is where I start making more profit than I am cost right here. So my break point, I got to find the intersection now. Menu, analyze graph, intersection. I know you guys are writing these down, right? You're writing it down. Okay, because it's important to write these steps down. Menu, analyze graph, intersection. Lower bound, so move to the left of it. Upper bound, move to the right. Alright, so I will show you on this. So I'm going to take my mouse. I'm going to click on text. And I need to do, yes, it's scientific notation. And I'm going to change that for you right now. So right here, you click on the text, and I believe it is, can't see it from here. Whichever is the right click, because it's kind of blurry on my screen. So is it menu? No, it's not that one. It is control menu. There we go. You hit control menu and you go to attributes. So right here, click on it. Control menu, attributes. Where'd it go? Why is this not doing it now? Attributes, there we go. And change this to be 6. Yes. Okay, I clicked on it. I clicked on it. And once I click on it, I go control. Dang it. Now this is going to give me a hard time. Why does this not want to do this now? Attributes, and I don't know, go 6 or 7. You'll have enough. If you just need to go a bunch more. What? Yeah. So if you notice right here, I eventually got this right here to click on it, and I'll get my answer. So I wanted to have this so I could see as many zeros as is there. So what does it say? So my x value is 2,500. So what does that mean in this problem? That means what? I sold that many. So my break point I sell 2,500. So if I sell 2,500, that's my break-even point. That's the point where I have to figure out, okay, I need to sell at least this many to break even. So everything I sell on top of this is going to be profit, more profit. Yes. All right, I have my, this is going to be how much it costs. Am I missing a 0? One more 0. There we go. So at 1.5 million, I sold 2,500, and then that's my break-even point. Now, the last part that I have here is going to be, so here's the graph. This is what they have on theirs. Now, the profit function. The profit function is always going to look like this. The profit function is always going to be revenue minus cost. Whatever it is, revenue minus cost. This is the last page, and it's already set up for you so you can see this. So the revenue minus cost. So now I'm in the negative until I sell 2,500. So right here, we take this, I distribute a negative into this function here. So I get 600 minus 400 gives me 200, then minus 500,000. So this is going to be my profit. So I'm going to lose money until I finally actually sell 2,500 of these. That's what that means. So you will have to set up a profit function. Make sense? Yes? No? Maybe? No? What's wrong, Tejan? Okay, so when we combine both of these together, when I combine both these together, I had my revenue minus cost, right? That's what it starts out as. Okay, so if I make no money, did I lose money? If I sell 0 wheelchairs, did I lose money on this? Yeah, I lost a lot, didn't I? So what I'm doing is, so my revenue was 600 x minus my cost function, which was 500,000. Enough zeros? Yeah. Plus 400x. So after I distribute this, I get minus 500,000 minus 400x. Okay? P of x, right there. 600 minus 400 gives me what? 200. So every single wheelchair I sell, I only can make how much off each one? 200. That's what the profit is. And there's nothing to combine to this, so it's minus 500,000. So, let's think about this. So if I sell one wheelchair, I'm losing money, you know what I mean? So let's figure out how much money I lost if I only sell one wheelchair. So my profit on this is going to be, for one wheelchair, it's 200 times 1 minus 500,000. So that's going to be 200 minus 500,000. So that's going to give me a negative 400, 900, 98, 0, 0. Like that. And this is how much money I made. I'm making negative $499,800. So I need to start hustling and selling a bunch of these wheelchairs, right? But if I sell more than 2,500, because that was my break-even point, if I sell 2,500 or more, all this is going to be positive numbers. But if I sell less than that, all this is going to be negative numbers. So that's what the break-even point's for. Okay? So at some point, you might have a business, you might have to run Ranch Market or something, and you're going to have some profit. Okay? And that's what you're going to work on. You're going to do some of this. All right. Hopefully you guys okay with that. We're going to use the rest of this time, hopefully, to get some of these problems done. I will come around and help you if I can, but if you're asleep, I can't help you. Okay? So make sure you like, share, subscribe, hit that notification button, and support my channel. I'm going to put some new merch up here next week. So